Hi, my name is Jens, and I want to show you a little preview into WunderBase, which is a serverless SQLite-based database with a GraphQL interface. So you can see at the bottom here, we have graphical running. So one instance running, it's running on Firecracker, or more specifically, it's running on fly.io. So Fly, they have a thing that's called machines, and machines, that's essentially the REST API that allows you to run Firecracker instances. And this API, it's quite fast, so you can start and stop a Firecracker instance within a couple of 100 milliseconds. You can attach a volume, and so I had the idea, if I can quickly start and stop a Firecracker instance, I could put an SQLite database inside this Firecracker, and I can put a GraphQL interface on top of that. So it speaks HTTP, and HTTP is perfect because it can be used to wake up the Firecracker instance. And so when we make a request from our playground here, it wakes up the instance. And then if we don't do requests for 10 seconds, that's how I programmed the backend. If you don't do requests for 10 seconds, the machine falls asleep again. So we can check this out. So if I click here, you can see that it took, in this case, it took 900 something milliseconds. You can see that the machine here, it became reachable in 30 milliseconds. And then after a while, the machine stops again. And so we can create a couple of posts. So again, if I do the first one, you can see now it's 720 milliseconds. It wakes up the machine. It processes the HTTP request. And if we do a couple more, you can see that the latency between, because it's hosted in Frankfurt and I'm near Frankfurt, so it's quite fast. So it's 13 milliseconds, and we're creating a bunch more posts. And then if I get all the posts, you can see, okay, now we get all of them within 10 milliseconds. Again, I wait 10 seconds, not making any requests. The machine stops. And if we reboot it again, 700 milliseconds. So it's always something between, like, I would say 300 to 500. In this case, it took a bit longer, but that's perfectly fine for a serverless database. And serverless in this instance means that most of the time, this database, it can actually sleep. It doesn't do anything. And there's a whole lot of use cases, I think, where people have pet projects or they try something out where they can use a database like this. And the other use cases, let's consider you have a main branch, and this main branch, it's connected to a Postgres database. So that's your production workload. And whenever you create a new experiment or a new branch, or you try out some feature, in this branch, you could make changes, use a serverless cheap database like the SQLite based here. It can have the exact same database schema. It can therefore have the same GraphQL API it exposes. And internally, instead of using Postgres on the second or dev branch, you can use SQLite. So you can very quickly spin up new instances of this database, try out stuff, and if you're convinced that you want to merge it into main, on main you can either use SQLite as well, or even something like Postgres, or maybe even Neon, which is a serverless database for Postgres. But in our instance, I think there's a whole bunch of use cases where you want a super cheap way of providing a database. And I think SQLite is excellent for that. There are many use cases where the application is actually not doing anything most of the time of the month. And so if you look at Fly machines, what you pay for is 15 cents per gigabyte storage. So our bottom line of cost, if we don't consider the free quota they offer, we have 15 cents for the storage, and then, I don't know, a couple more cents for the time that our database is actually running, and yeah, some more cents for the traffic that we generate. So if you sum this up, you can look at solutions like like DynamoDB, for example, where you are locked into an ecosystem, and with WunderBase, which we're going to make open source, you can have a database super cheap. So we definitely want to offer a managed service on top of that with free quotas. And so it can be extremely cheap. It can be extremely easy to use because we can provision such a database in 30 seconds or even faster. And all you have to do is define a Prisma schema. We auto migrate the service, and then once you make a request, you can see that, okay, this was 790 milliseconds. The fly machine wakes up, it processes the request, it gets persisted, and now the machine is sleeping again. And if you're thinking about, okay, is this production ready or something? So I scaled this on my local machine to around 10K RPS for reads, and it was, I think, 2K RPS for writes. So it's quite fast actually, and a lot of workloads should not exceed that. And there's also tools like Lightstream, for example, where you can take the writes from your SQLite database, and you can stream it onto S3. And this means we also got backups and point-in-time recovery, which I think make up for an excellent service. And yeah, we want to bundle all of this together so that you get a super nice serverless GraphQL database with the storage as the backend, with backups and everything. And yeah, that's all I wanted to show. And I'm super curious what people think about this stupid, simple approach to building APIs. Okay, see you guys.